Hello everyone, Professor Algebraic here, and in this video I want to talk about how to solve limits numerically. Now we should always solve limits algebraically if we're given a function, and graphically if we're given a graph, but sometimes there's certain discontinuities that occur at the point that we're solving the limit of the function for, and we can go a step farther and analyze numerically what's happening at that point to see if there's something that we can extrapolate. For example, if we have the function f of x is equal to 1 over x, and I wanted to take the limit as x approaches 0, right, we can do this pretty straightforward. We just plug in 0 and we see that we have a 1 over 0, which if you watch my last video on how to solve limits numerically or algebraically, you would see that this we called undefined. Okay, but we know if we have a number on top and a 0 on the bottom that there is a vertical asymptote. And we know looking at the function of 1 over x that there is a vertical asymptote at x equals 0. So what can we do? Okay, we want to make a table. And what we're going to do is analyze what's happening at and around 0. Alright, so 0 is kind of our target point. Now normally when we make a table we'd put -1 and 1 as our next two numbers. But what I want to do instead is look at things very close to 0 on either side, right? So maybe I want to look at 0.1. Maybe I want to look at 0.01. Maybe I want to look at 0.001. And the same thing on the negative side. Okay, so we're going to analyze what's going on at these points that will exist because we won't be dividing by 0 anymore to see if we can figure out what's happening with the function and decide what the limit is going to be. Now we should know what this function looks like. I chose an easy one so we can see, knowing what the result's going to be, how we get that result. Okay, so if we take something like 0.1 and we plug it in for x, we have 1 over 0.1, which is 10. And if we do 0.01, picking a number getting closer to 0, we're going to have 1 over 0.01, or 100. And if I pick something like 0.001, we're going to have 1,000. So if I pick something even closer to 0, I put some more zeros in this decimal before having a 1, this number is getting bigger and bigger, right? We have a whole number on top and we're dividing by a ever increasing small number. Where the number on the bottom is getting smaller and smaller and smaller, which means what we equal to, right, having a big number over a very, 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 very small number is going to give us a very large number, right? This number is going to increase and increase and increase the closer we get to 0. So as we approach 0 from the positive side, we're getting closer and closer to positive infinity, right? So we can say that the limit as x approaches 0 from the positive side of our function is going to be equal to positive infinity. We can do the same thing coming from the other side, right? We can plug in, well, negative 0.1. 1 over negative 0.1 is going to be negative 10. 1 over negative 0.01 is going to be negative 100. 1 over negative 0.001 is going to be negative 1,000. Right, so as I'm putting in close numbers that are closer and closer to 0 from the negative side, from the left-hand side, we can see that our result, being a big number over a very, very, very small number, is giving us a very large negative number, meaning that as we approach 0 from the left-hand side, we're getting closer and closer to negative infinity, meaning the limit as x approaches 0 from the left-hand side of f of x is equal to negative infinity. Now we know from our introduction of limits that because the right hand side and the left hand side are not equal, then this limit does not exist. Right? But if we do this numerical analysis on something like 1 over x squared, we'll see that on both sides we end up with positive infinity. Okay, so whatever function you have that has that vertical asymptote, we can analyze left and right limits numerically just like this. You might have a more involved function, but the process and the idea is still the same to decide if you're going to be going towards positive infinity at that asymptote or negative infinity at that asymptote from both the left side and the right side. If they're the same, if they're both positive infinity, then you can say that the limit as x approaches that number is positive infinity. If they're both negative infinity from the left and from the right, then you can say that the limit as x approaches that number is negative infinity. Okay, but this is the idea, this is the process, and we can apply this process to any function that has a vertical asymptote to identify what's happening to the left and to the right of that vertical asymptote and identify if there is a limit that exists at that vertical asymptote. Alright, well, I hope this video was helpful. If it was, consider giving it a like and consider subscribing to the channel for more videos like this and more math content. Thanks for watching, good luck, and we'll see you in the next one.